Before we get to tire models that in turn are needed to derive the equations of motion for the dynamic bicycle model, let's start off with some terminology and basics on vehicle tires. To begin with some basic terminology, let's look at this image of a wheel. The wheel is composed of two parts. The outer part is the actual tire, and it can be seen as an elastic torus that's made mostly out of rubber, and an inner part which is called the rim, and it can be seen as a solid disc that's made up of metal, usually aluminium or steel. Now let's look a little more closely specifically at the tires. In more detail, a tire consists of a combination of rubber and fabric, where the fabric construction is also referred to as the tire's carcass. So the carcass is made up of cords which are rubberized. After the Second World War, it was popular to use cotton, which was enforced by rayon. Today, other materials such as nylon, polyester, or fiberglass are used for those cords. The cords are arranged in usually two or more layers, which are also called plies in tire jargon. The two main construction types are radial ply and bias ply tires. The two types are best explained by looking at a cross-section of a tire, which is shown down here. For the radial ply tire, the plies run perpendicular to the tire's circumference. For the bias ply tire, on the other hand, the plies are arranged in an alternating fashion, as shown here, where the cords are running at an angle of about 50 to 55 degrees to the tire's circumference. Of course, both types of tires have their advantages and disadvantages. The older type is the bias ply tire, which has been developed in 1896 as a successor to a full rubber tire. Advantages of bias ply tires are that they are more stable and more robust against sidewall damages. The radial ply tire has been developed in 1946 by Michelin. While it is generally less robust than the bias ply tire, it has some advantages, such as a better steering property and a better road contact. Also, it leads to a lower fuel consumption and it heats up less than the bias ply tire, especially at high speeds. Now let's look at some further terminology regarding the dimensions of a wheel. To this end, a wheel has been drawn from the front perspective and the side perspective. Note that you can find the most important dimensions also stated on the tire. They are expressed in what's called a tire code. So for example, if you look at the tire at the top, you can find the tire code down here. Probably the most obvious dimension is the rim diameter, which you can find in the tire code at this position. Note that this number here, 19, is stated in inches. Second, and let's move through the tire code backwards, the letter R stands for a radial ply construction. Third, the first number of the tire code refers to the section width, which is essentially the width of the tire. And in this case, it's 255 millimeters. And finally, the second number of the tire code refers to the aspect ratio, which is the ratio between the section height and the section width of the tire, with the section height being the height of the tire. Note that in this case the number 45 means that the aspect ratio equals to 45%. Another important dimension of the tire is the tread width, which is obviously the width with which the tire touches the ground. Looking at this a little further from the sidewards perspective, the tire does not touch the ground in just a single point, but there's a whole contact area between the tire and the road, and this area is called the contact patch. As an immediate consequence, the tire radius at an unloaded point of the tire is not the same as the effective radius at the loaded point of the tire. In fact, we have that the effective radius is somewhat smaller than the tire radius due to the load on the tire. As the last part of this video, let's look at the wheel coordinate system. This is again our sketch of the wheel from a sidewards and a frontal perspective. For the sidewards perspective, we assume that the leading edge of the wheel is to the left and the trailing edge of the wheel is to the right, meaning that the direction of travel of the wheel is to the left here. For the frontal perspective, we assume that the direction of travel is into the plane. So we're basically facing the trailing side of the wheel and the leading side of the wheel is behind the plane. We already see the wheel spin axis in blue in the frontal perspective and the sidewards perspective. And now the wheel plane is defined as the central plane of the wheel that is perpendicular to the wheel spin axis. Now looking at the intersection of the wheel plane with the road plane, the wheel plane passes through the middle of the contact patch. And this intersecting line of the wheel plane and the road plane is called the tire center line. The wheel coordinates xw, yw, and zw are now defined as shown in the two diagrams. In particular, the xw axis is pointing in the direction of travel of the wheel, which in the frontal perspective is pointing into the plane. When looking into the direction of travel, the yw axis is pointing to the left, so it's pointing outside of the plane in the sideward diagram. And finally, the ZW axis is pointing to the top.